SQL ordered by gets. The SQL ordered by gets section of an Oracle AWR report lists SQL statements that have incurred the highest number of buffer gets during the period. This section provides info on how many blocks were read, i.e. logical reads from buffer cache. Buffer gets, this column represents the total number of buffer gets, data block accesses, incurred by each SQL statement during the snapshot interval. Executions, the executions column indicates how many times each SQL statement was executed during the snapshot interval. Gets per exec, this column shows the average number of buffer gets per execution of the SQL statement, calculated by dividing the total buffer gets by the number of executions. Percent total, the percent total column shows the percentage of the total buffer gets incurred by each SQL statement in relation to all the SQL statements listed in this section. Elapsed time, this column represents the total elapsed time, in seconds, spent on executing each SQL statement. It includes both CPU and I/O time. Percent CPU, the percent CPU column indicates the percentage of CPU time consumed by each SQL statement in relation to the total elapsed time. Percent I/O, the percent I/O column represents the percentage of elapsed time involving I/O, input-output, operations, suggesting the I/O related performance impact. The SQL statements in this section are ranked by the total number of buffer gets they perform. The top SQL statement is performing a massive number of buffer gets 237,214,741, which might indicate a heavy reliance on database buffers and data retrieval. The SQL statements were executed multiple times, ranging from 1 to 15,524 executions. The SQL statements have a high number of buffer gets per execution, ranging from 15,292.03 to 50,011,404.00. The top SQL statement accounts for approximately 32.06% of the total buffer gets. The variation in elapsed times and the percentage of CPU and I/O time indicate differences in the nature of these SQL statements, some being more CPU-bound, while others are more I/O bound. The SQL statements have a significant percentage of CPU time usage, indicating they are CPU intensive. The top SQL statement had a percent I/O value of 0, indicating minimal I/O time, while others have higher percent I/O values, implying significant I/O activity. A high number of buffer gets is one of the main indicators of SQLs with suboptimal execution plans. If CPU other constitutes a substantial portion of the overall response time, it suggests that a considerable amount of time is dedicated to retrieving and manipulating blocks and buffers. Further analysis is required to optimize these SQL statements, especially those with exceptionally high buffer gets, to improve database performance and resource utilization. In the SQL ordered by reads section of an Oracle AWR report, lists SQL statements that perform a significant number of physical reads. Physical reads, the total number of physical reads performed by each SQL statement during the specified time interval. Physical reads involve fetching data blocks from disk into the database buffer cache. Executions, the number of times each SQL statement was executed during the specified time interval. Reads per exec, the average number of physical reads per execution. It's calculated by dividing the total number of physical reads by the number of executions. Percent total, the percentage of total physical reads in the entire system attributed to a specific SQL statement. This helps identify SQL statements that contribute significantly to the overall I/O load. Elapsed time, the total elapsed time spent executing each SQL statement. Elapsed time includes both CPU time and wait time. Percent CPU, the percentage of total CPU time spent by each SQL statement. It provides insights into how much CPU resources are consumed by a particular SQL statement. Percent I/O, the percentage of total I/O time spent by each SQL statement. It indicates the proportion of the SQL statement's total time spent on I/O operations. Top SQL with the highest number of physical reads has a very high number of physical reads, 2,666,094, accounting for 5.01% of the total. SQL with significant physical reads and insert operation has a high number of physical reads, 2,666,084, contributing to 5.01% of the total. SQL with substantial reads and select operation has a considerable number of physical reads, 2,232,875, constituting 4.19% of the total. This SQL consists of a PL/SQL block with a significant number of physical reads, 1,748,610, contributing to 3.28% of the total. This SQL involves another select operation with a substantial number of physical reads, 1,659,260, accounting for 3.12% of the total. By analyzing this section, database administrators can identify SQL statements that are causing a significant number of physical reads. Optimizing these high-read SQL statements can lead to improvements in overall system performance, especially in scenarios where I/O operations are a bottleneck. Physical reads column in the SQL ordered by reads, which counts database blocks read from the disk not actual I/OS. A single I/O operation may return many blocks from disk. Physical read recs column in the SQL ordered by physical reads, UnOptimized, section is the number of I/O requests and not the number of blocks returned. The SQL ordered by physical reads, UnOptimized, section of an Oracle AWR report lists SQL statements based on the number of physical read requests, unoptimized. They've generated during the specified snapshot interval. Read requests that are satisfied from the Smart Flash cache are termed optimized since they are returned much faster than requests from disk. Additionally, read requests accessing storage indexes using smart scans in Oracle Exadata v2 also fall under the category optimized read requests since they avoid reading blocks that do not contain relevant data. In database systems where optimized read requests are not present, unoptimized read recs will be equal to physical read recs, I/O requests satisfied from disk. In this case, columns unoptimized read recs and physical read recs will display the same values and column %opt will display 0. Unoptimized read recs, this column shows the number of unoptimized, suboptimal, read requests, where a physical read was performed. Physical read recs, this column represents the total number of physical read requests made by each SQL statement during the snapshot interval. Executions, the executions column indicates how many times each SQL statement was executed during the snapshot interval. Unoptimized recs per exec, this column calculates the average number of unoptimized read requests per execution. It is obtained by dividing the number of unoptimized read requests by the number of executions. %opt, the %opt column represents the percentage of optimized, efficient, read requests in relation to the total physical read requests generated by each SQL statement. %total, the %total column shows the percentage of the total physical read requests incurred by each SQL statement in relation to all the SQL statements listed in this section. The SQL statements in this section are sorted by the number of physical read, unoptimized, requests they've generated. The SQL statement with the highest number of unoptimized read requests generated 386,181 such requests and 6.98% of the total physical read requests. These highest number of unoptimized read requests might be inefficient and could benefit from query optimization, such as better indexing, caching, or rewriting the SQL statement. The SQL statements have generated varying numbers of physical read requests, with the highest being 386,181. These physical read requests involve retrieving data blocks from storage to satisfy SQL query requirements. The fact that some of these SQL statements were executed only once during the interval suggests that they might be ad hoc queries or not frequently used, and have a high number of unoptimized read requests per execution, indicating inefficiency. The low %opt, optimized read requests, values indicate a potential for better I/O efficiency in these SQL statements, possibly through the use of indexes, query tuning, or cache optimization. Analyzing and optimizing SQL statements with high physical read activity can lead to improved performance and reduced I/O related resource consumption. Physical reads column in the SQL ordered by reads, which counts database blocks read from the disk not actual I/OS. A single I/O operation may return many blocks from disk. Physical read recs column in the SQL ordered by physical reads, unoptimized, section is the number of I/O requests and not the number of blocks returned.